Today, we are going to be starting our next unit. This is going to be the unit called I See the Light. This unit, we're going to be talking about the electromagnetic spectrum, or electromagnetic radiation, aka light. So we're going to talk about different parts of the light, how amplitude, frequency, wavelength affect light. So it's going to be using a lot of what we talked about in our last unit, in the unit of sound and waves, and we're going to kind of translate those concepts over into the concepts of how they work in both amplitude, frequency, wavelengths, and all that, and how that translates over to light. So light. Light is another word for it in the more scientific term. It's called the electromagnetic radiation. Now, what is radiation first off? When you look at radiation, you think this symbol, right? The, ooh, bad, mutations, cancer, Chernobyl, nuclear bombs, bad. But radiation is not what you're thinking, okay? It is not that symbol. Radiation just means to give off something. Like a radioactive particles, which is radiation, but it radiates particles that can be harmful to humans. But if something can also radiate light, a fire radiates light, but it is not going to give you cancer. This is not a light bulb radiates light but you're not turning into the Hulk or anything like that. So that idea of radiation is kind of it's gotten a bad name. But anything that emits or gives off light or waves is said to radiate. So when something gives off light, it's radiating something. It's in a form of energy. And this is what we refer to as light. So remember that waves transfer energy without transferring matter. So light waves transfer energy, they're not transferring any matter, and when they do that, they are going to transmit that light in various different ways. Now, the type of light is dependent upon the frequency. Just like mechanical waves and their pitch, frequency determines the pitch of a mechanical wave, such as sound. Electromagnetic waves, the frequency determines what kind of type of light. And we're going to talk about the various different types of light here in just a moment. Now, the amplitude is determined is volume. So this is like our sound, how loudness for sound. But in electromagnetic waves, its intensity, it's how bright that light is based on the amplitude. Now, light, unlike mechanical waves, light can go through empty space. Light does not require a medium. Mechanical waves all require a medium. Light does not. Electromagnetic waves are not vibrating material, but they are vibrations of pure energy. So they can travel through empty space. That's how light comes to us via the sun. It is not material. It's not traveling through material in space. Space is a vacuum. Now, light can be broken up into different parts. We call this the electromagnetic spectrum. Those different parts are based off of their frequencies. So, the electromagnetic spectrum has these. You will need to know their names and their relative orders of each other. You'll need to know their relative wavelengths, frequencies, and energies. You do not need to know their numbers, but you do need to know that radio waves comes before microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. You need to know that order and that the longest is radio waves and the shortest is gamma rays. You need to know those. So let's go through this. Radio waves. Radio waves is the longest wavelength, lowest frequency type of light. Radio waves, these are the waves that are coming from, that go into radios. It's also what's TVs. So TVs don't work off of TV rays. That doesn't exist. Those are radio waves. Your cell phone uses radio waves. Communication is done through radio waves, and their wavelengths are about the size of football fields, if not humans in size. And the frequencies are going to be very, very low frequencies. And in fact, if you pick any radio station, that radio station is actually in the megahertz range, which is right about here. That's your megahertz. And so if you're listening to something 105.9, the radio station 105.9, that's 105.9 megahertz. That's right about here. And that's the frequency of that radio station. Now, microwaves are the next one. And they're the next larger than, or smaller wavelength than radio wave, larger in frequency than radio. Microwaves are used in microwave ovens. That's how they heat it. But they're also used in communications as well, and they can be, they're kind of in between the next group. Now, infrared is what our body feels as heat. We cannot see it, but we feel it as heat. So when a fire gives off that heat, that is the infrared light. Again, smaller wavelengths than microwaves or radio, but bigger frequencies than your radios and micros. Now, visible light is only a small smidgen, a sliver of light that was able to be visible by the human eye. Now, some animals can see infrared, such as snakes, pit vipers, like rattlesnakes. They can actually see the infrared. They see heat, so they can see warm-blooded creatures at night without actually needing to see in the visible light. Humans, on the other hand, we can only see the rainbow of colors, the Roy G. Biv. Now, red is next to infrared. Infra meaning below, red. So red belongs with red. So red is a longer wavelength, lower frequency. Then you go all the way up to violet, which is over here on our other end, which has a higher frequency but lower wavelength. And the above violet is ultraviolet, UV. This is what's going to cause suntans. This is what's going to, some ultraviolet can kill bacteria. Some people have ultraviolet little toothbrush holders, and has a little black lights. Black lights are also an ultraviolet radiation. The ultraviolet we're starting to get to the energies that can be damaging. Now, the next group is X-rays. This is the same ones used to take X-rays in your arms, broken bones. It has a high enough energy that it can penetrate through most material with the exception of like dense bone. So X-rays here are really, really short, small wavelengths, the size of atoms, frequencies that are really ridiculously high now. And then the last one is your gamma rays. These start getting into the point where now we're getting so much high energy that it can actually mutate and destroy DNA. These are in the orders frequency, 13 zeros, then a 1 in its wavelengths. So the size of an atom or atomic nucleuses. And we're also talking about frequencies that are astronomical frequencies. So gamma rays are found in nuclear devices, nuclear bombs, but also in medicine when we do nuclear medicine, where we use it for radiation therapy, where we can take a gamma ray laser, shoot it at a cancer tumor, it rips and destroys that DNA while leaving the rest of the human body not to having to suffer that. There is a consequence though, because gamma rays emit so much energy that it could damage neighboring and irradiate neighboring cells, causing them maybe in a future time to also become cancers. So that's why you use chemotherapy more often than radiation therapy. So you'll need to know that radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gammas are in this order according to lowest to shortest wavelengths, lowest to highest frequencies. Now, energies also happen to follow the frequency. So lower energy radio waves, higher energy gamma rays. Energy you can think of as destroying, breaking stuff, moving things. So energy is going to be your gamma rays can give you cancer. X-rays, if you get a lot of them, Not one every couple of years is not bad. You get them for your teeth all the time. It's not going to give you cancer, but if you get lots of x-rays, not good for you. Ultraviolet, if you get exposed to suntans, it's going to give you some form of could give you cancer, maybe if you keep getting sunburns over time. But visible, not going to give you cancer. Radio, definitely won't give you cancer. So, you need to know these orders. You do not need to know the numbers. You also need to know the orders of the light, the Roy G. Biv, and that is in this order. Now realize on the test, I could ask you it backwards. I could say, give me the order of the electromagnetic spectrum from shortest wavelength to longest, highest frequency to lowest, or highest energy to lowest. So realize, be careful on that. Now, we're going to watch a movie here, and I'll let you enjoy.
Electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. From the TV station to your living room, that is the work of radio waves. Heating food in just seconds, microwaves do that. Heat treatment for illness, take pictures in the dark. They are even in your remote control. Infrared radiation, the electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Red, orange, yellow, green, blue, indigo, violet. That is the only part of the spectrum that can be seen by us. The suntan on your skin kill bacteria and viruses. Used to detect forgery, that is ultraviolet. The electromagnetic spectrum is just the name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. See your broken bones and your hidden bombs, that is the work of X-rays. Kill cancerous cells and sterilize dangerous gamma rays, do that. Now we have completed the electromagnetic spectrum. If you still do not understand, then play the song again. The electromagnetic spectrum is just a name of a range of radiation. Let me tell you what they are. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays.
All right, electromagnetic energy of the energy of electromagnetic energy is directly related, is in the form of electricity and magnetism. The wavelength of the frequency tells us the type of radiation it is, and the amplitude tells us our intensities. So again, this is just kind of going over it. One of the things you want to know is that nano means 1/billionth or times 10 to the negative 9th. So 700 nanometers in scientific notation would be 700 times 10 to the negative 7th. You put that in your calculator, you'll get 7 times 10 to the negative 7th meters. So we'll let you leave off that. If you have any further questions, ask your teacher.